Today we are going to look at the ladder editing interface of the software. First, open the ladder editing interface. The software needs to load a piece of ladder. The ladder can be taken directly by the camera or imported into the picture already taken. Let's select a ladder image to import. You can see that the software has automatically identified the contours and flaws of the ladder. We can manually add or subtract contours and imperfections. You can also add or modify levels. When the defect visibility is low, we can adjust the value of flaw visibility to enhance the recognition ability. After the ladder is edited, it can be directly imported into the nesting interface, and then it can be nested. Okay, let's move on to the manual seed feature of the ladder editing interface. When the background is really messy, if the auto recognition contour doesn't work well, we can use the manual seed function. Click the ladder button to circle the inner part of the ladder and the outer part of the ladder. Then click the recognize button to identify again. As you can see, the contour can also be identified. This is a simple introduction to the ladder editing interface. A brief introduction to automatic nesting. Automatic nesting consists of two main steps: normal nesting and fine-tuning nesting. Normal nesting optimizes the global. Fine-tuning nesting optimizes the local. We prepare the cut pieces and raw materials to be nested, and set the time for normal nesting and fine-tuning nesting. Click the Start button for automatic nesting. Fast forward the nesting process. At the end of the nesting, zoom in to see that the cut piece has been tightly nested into the material and automatically avoids the defect area. Looking at the remaining number of cut pieces, we found that some had more and some had less. In some industrial production, we hope that the cut pieces can be cut in pairs as far as possible, so that there can be a better consistency. The software supports the complete set of discharging function. Let's look at the following parameters. Single, the number of pieces in a set. Sets limit the number of sets to be nested into a group. Supersets num, restrict the set nesting from later sets when the set nesting cannot be computed. Maximum difference in number of sets 等于 sets limit single 一加 supersets num. If we set superlimit to 3 and supersets num to 1, we can get a maximum difference of 6. Click the Start button again for automatic nesting and fast forward the nesting process. At the end of nesting, it can be seen that the difference of the maximum remaining quantity of cut pieces is indeed not more than 6. Automatic nesting can be operated in this way to strictly control the number of cuts. More features need to be experienced by you. Manual nesting is a brief introduction. Prepare the cut pieces and leather to be nested. We can drag the cut piece directly onto the leather. Cut pieces can be moved, rotated, mirrored, combined, and a series of operations. After placing the cut piece, it will automatically adsorb to the edge. Shoes, bags, and other processes. Manufacturers often need to put the most important pieces nested first. In our software, you can do continuous placement directly. There are more efficient ways to do this. Select the cut sheet for array placement. The software supports both local and global arrays. Array blocks can be customized into modules and imported into groups for easier use. After placing the cut pieces manually, the remaining part can be completed by the automatic nesting function of the software. More features need to be experienced by you. A brief introduction to hierarchical nesting. This software supports a total of 5 levels. The rank order is A, B, C, D, and E. When nested, the lower level can be in the higher level area, and the higher level cannot enter the lower level area. Open the CAD editing tool of the software and import the prepared cut pieces. We need to edit the level according to the customer's process requirements. The mapping relationship between toolbar color and level is A green B blue C, brown D, gray E red. After the level is edited, import to the nested interface. Next, we open the scanning interface and import the ladder material that needs to be drained. As you can see, the software automatically assigns level D to the marked defects. Here we manually add some levels. After importing the ladder material into the nesting interface and setting parameters, we can click the Start button for nesting. Because of the large computational power of nesting, here we fast forward by 10 times. That's the end of the nesting. So let's look at the nesting result. It can be seen that the discharge of different level areas is mainly of this level, and many defects of level D are in the D area of the cut sheet. Customers can also adjust nested parameters to obtain a variety of desired results. More features need to be experienced by you. A brief introduction to feed function. Feeding function is a special production process demand. In industrial production, part of the cut sheet is the sewing edge, so this part can be slightly missing. This software supports external feed function and internal feed function. The external feed function allows the cut section to be nested on the outside of the leather. The internal feed function allows the cut sections to overlap each other. Next, we will demonstrate the feed function. Prepare the leather to be nested. Then we enter the CAD editing interface. Import the cut file. In this software, level D can be marked as the feeding function area outside the cut piece, and level E can be marked as the feeding function area inside the cut piece. We quickly edit the cut level in the software. After editing, import into the order. Set the maximum external feeding distance to 5. Click the Start button for quick nesting. At the end of nesting, we check the result. We can see that part of level D area of cut pieces is on the outside of raw materials and defects. Level E area of cut pieces overlaps. When overlapping, the feeding function needs to optimize the cutting path to avoid bad cutting pieces. After we export, we can observe You can see that the cutting path has been automatically optimized by the software. More features need to be experienced by you.